Welcome to Homework Lib.
In this problem, we're told that a car was valued at $30,000 in the year 1990. However, 10 years later, in the year 2000, the value was only $13,000. So, in part A, we want to figure out the annual rate of change from 1990 to 2000. So, in order to do this, we're going to use our exponential decay function. So, here's how it works: A of t, the amount after t years, is equal to a sub 0, the initial amount, times 1 minus r, which is the rate it decreases, all raised to the t power. So in this case, what we're going to do is we're going to let when t equals 0 represent the year 1990. So in this particular case, that would mean that our initial amount is $30,000. So that would be our a sub 0 value. Now, we know the value 10 years later is 2000, meaning when t is equal to 10, a of t was 13,000. So we have 13,000 equal to 30,000 times 1 minus r, which is what we're looking to solve for, all raised to the 10th power. So now we want to go ahead and solve for r. So the first thing I'm going to do is divide both sides of our equation by 30,000. And I'm not going to put this into my calculator quite yet, but I know those three zeros at the end will cancel. So we have 13 over 30 equal to the 30,000s cancel. And then we're going to have 1 minus r all raised to the 10th power. So now the opposite of raising something to the 10th power is to take the 10th root. So we're going to take the 10th root of both sides of our equation. So we'll have the 10th root of 13 over 30 equal to, well, the 10th root of something raised to the 10th power cancels each other's out, which leaves us with 1 minus r. So now to solve for r, we'll first subtract 1 from both sides. So we have the 10th root of 13 over 30 minus 1 equal to negative r. But then we have to divide both sides of our equation by negative 1. So if we divide both of those terms by negative 1, we'll have minus the 10th root of 13 divided by 30, and then plus 1, all equal to r. Perfect. So now we can type this into our calculator. So I'm going to do minus the 10th root of, and I apologize, I typed something in wrong. So again, it's minus the 10th root of 13 divided by 30, and then we're going to add 1 to it. And in this case, it looks like they want you to round 4 places after the decimal, which means your r value would equal to 0.0802. So that's the value for r. So now let's take a look at part B. So part B of our problem says to take the answer we get in part A and write it as a percentage. So remember, r is our percentage as a decimal. So to make it into a percent, what we have to do is multiply by 100. And remember, to multiply by 100 means we move the decimal point 2 places to the right. So our bar value in terms of a percent would be 8.02%. Great. So now we have A and B all set. Let's take a look at part C. So it says to assume the car is going to continue to drop by the same percentage per year. We want to know the value in 2004. Well, 2004 is 14 years after 1990. So T in this case will equal to 14. So we're looking for A of 14. So this will equal to the initial amount, what the value, which was $30,000, times 1 minus R, which remember we found to be 0.0802, and our T value, the number of years, is 14. Great. So now we just have to put this into our calculator. So we're going to do 30,000, parentheses, 1 minus 0.0802, close the parentheses, and for your exponent, 14. And in this case, they want us to round to the nearest $50. So if we went to the nearest dollar, it would be 9,307. So if we're rounding to the nearest 50th, we're trying to look at our last two last two place values. Well, is 7 closer to 0 or closer to 50? Well, 7 is much closer to 0, meaning if we're rounding to the nearest 50th, the value of the car would be worth approximately $9,300.